So here's the review. First off, graphing. If you got multiple choice and you just have to pick the graph, it's going to be fairly simple. I'm pretty sure it's either multiple choice and you pick the graph, or you're just like having to identify the asymptote. There's not like a graphing section on it like there was on the last test. This one, 3 times 2 to the x means it's 0. It's going to be 1, 2, 3. This is exponential, so it's going to curve up on the way back. It'll turn into an asymptote. So it's going to go kind of like that. 1/3 times 3 to the x means at 0. It's going to be at 1/3. Similar kind of thing. It's just going to be a more extreme curve because it's 3 to the x. Keep in mind that as this goes back on both of those, it will never touch 0. 0 in both of those cases, y equals 0 is going to be our asymptote. We can't touch it. We can't get there. All right? This one, same kind of thing. When it's 0, 5 to the 0 power is 1 times 0.25. We're right here. It's a much more extreme curve because it's 5. But again, y equals 0 is our asymptote. The further you go to the left, the closer this is going to get to 0, but it's never going to get there. You can pull it up on the calculator and scroll back in the table, and by the time you get to like -100, it'll probably start rounding it to 0, but if you check specifically in there, it still has decimal value. Like, it just gets really small when the calculator has a rounding issue. On this one, 2 times 3 to the x, this is going to be at 2, and it's going to go curving up like that. Again, we get closer and closer to 0. We never touch it. Our asymptote is y equals 0. On this one, 4 to the x minus 2. This is the only time that the asymptote moves, is when we have something out here that's changing it. 4 to the 0 power would be 1, but that minus 2 means we're going to move down 2 to right here. So this is going to go like this, and my asymptote is y equals -2. I am never going to touch -2. I'm going to get closer and closer to it, but it's just not going to happen. This one, 2 to the x plus 5, means I'm going to move 5 to the left. 2 to the 0 power would be 1, so that's going to go 1, 2, 3, 4, 5 to the left there, and that'll be like this. It's tough to tell how it moves because of the nature of these graphs. Y equals 0 is still my asymptote that I'm never going to get to. Okay? Again, there's not a graphing section like there was on last test. There is at least one problem that's like one of these 3 that is not multiple choice on the test. It's going to be you set the problem up. You don't have to solve it. You just have to be able to set it up. On this one, virus spread through networks of computers, 25% more are infected. It's increasing. So that's going to be 1.25. That's going to be our multiplier. It starts on one computer, so that's 1 times 1.25. And then how many computers will be affected after 10 minutes? That's to the 10th. 1 times 1.25 to the 30th. And then 1 times 1.25 to the 60th for the hour mark. Huh?
Why is it 1.25?
25% is the increase. We are already at 100%. So 25% increase on 100% is 125%. So that's this. Okay, on the second one, well, and if you remember from our notes, it's whenever you have the increase, 25% more, that's 1 plus my rate. So 1 plus the 0.25 gives me the 1.25. On this one, the depreciation means I have 1 minus my rate. So I take 1 and I subtract 0.15. That means that car at $30,000 is going to be multiplied by 0.85 raised to the number of years. So 0.85 to the 4th, 30,000 times 0.85 to the 8th, and then how long will it take to be worth less than half of the original value? You can just sit there multiplying it by 0.85 over and over again, if that's your bag, or you could just, especially like in Desmos, but you probably won't have Desmos on the test, like on the calculator, you can just graph 30,000 is equal to 0.85 to the x, and then also graph 15,000 because that would be half of that original value. What's up?
Why is it 0.85?
It's 0.85 because it's depreciating at 15%. It's losing 15%, but to get the value of the car, we multiply by the percentage that we are keeping. So if it's losing 15%, it's keeping 85%.
So you always take it from 100 then?
Uh-huh, yeah. It's just like with the increase, we always add it to 100%. With the decrease, we subtract it from 100%. Attendance for the basketball team declines 5% per game. That means that's going to be 0.95. The arena seats 23,500, and was full for the home opener. Predict the attendance after 2 years. I don't even know how to work this one because it doesn't say how many games, and it says it declines 5% per game. If we say 10 games per year, that'd be to the 20th power, something like that. I'm not too worried about it. Just be careful of something like this. If there's one like this on the test, as I work my way through it, I will let you know about it, but it's just kind of make sure you know how to set them up. On the back side, 3 to the 2x minus 1 equals 3 to the x plus 2. The bases are already the same. You could ignore it. It's 2x minus 1 equals x plus 2. That would be x is 3. On this one, 2 to the 3x equals 4 to the x plus 2. That's 2 to the 3x equals 2 squared to the x plus 2. All I'm doing is rewriting that 4 in base 2. I distribute this. I get 2 to the 3x equals 2 to the 4x plus 4. So I'm going to end up ignoring those 2's and solving the rest of it, which is going to be x equals a negative 4. On this one, whenever you have a fraction, this is 1/9. All you have to do is think of what you would have to do to get that base if it were a normal number, if it were just a 9, and then that exponent you're just going to make negative. So this is 3 to the 2x minus 1 equals 3 to the negative 2. This is actually going to be x equals a negative 1/2. We add 1, so that's a negative 1 over here divided by 2. It's a negative 1/2. 4, 5, and 6 are all going to kind of work that same way. 7, 8, and 9 are all going to kind of work that same way. I'll post the key to this. I'm just trying to kind of get through the video. Keep in mind with 4 and 8, you can't just square 4 to get 8. So you're going to have to reduce these both to base 2. That's 2 squared to the x plus 1 equals 2 cubed to the 2x plus 3. You'll distribute the 2 over here. You'll distribute the 3 over here. That's 2 to the 2x plus 2 equals 2 to the 6x plus 9. That's a negative 7 and 4. So x equals a negative 7 over 4. Okay, again, I'll post the key. I'm just trying to make the video a little shorter this time. Write a function to model the situation. $12,500 car depreciates 9% each year. That's $12,500, your starting value. We're depreciating, we're losing 9%. We multiply by what we keep, which would be 91% to the X number of years. A baseball card bought for $50 increases 3% in value. That's 50 times 1.03 to the X. Just remember, on like the single digit percentages, you have to have a 0. 3% is not 0.3, it's 0.03. 0.3 would be 30%. Okay? So keep that in mind whenever you have these single digit ones. A college with a graduating class of 4,000 students in the year 2008 predicts that its graduating class will grow 5% each year. Write an exponential function to model the number of students in the graduating class T years after 2008. Same kind of thing. Y is equal to their 4,000 students that they started with, times, it's an increase of 5%, 1.05 to the T, I suppose, T for time in this one. And then the rest of these are all the same kind of thing. Make sure you're paying attention to increase or decrease. The one thing that I'm not seeing on here, do make sure you still understand if it says like you are compounding quarterly. If you're compounding quarterly or compounding semi-annually, you take the interval, the number of times that you compound in a year, you divide your percentage by that, and then you'll multiply your amount of time, your exponent, by that same thing. Okay? All right, I'll get this posted today, and I'll get a key posted today.